Today I'm going to tell you a brief story that started from almost a year ago in Egypt. We are a team consisting of 9 members, but unfortunately 2 of us couldn't make the journey. However, we will assure that their work counts. From almost a year ago, we were searching for the ideas and solutions in order to accomplish our slogan, which is saving to the future. We put every skill we have and each experience we earned in order to finally come up with the Triton. It is our contribution to the ROV world, and it represents the outcome of our journey. Along this journey, we faced many obstacles, such as using some major electrical components, which will be explained later by the electrical team. This couldn't stop us from dreaming to come here to the competition, and as we worked hard to solve this issue. And this couldn't prevent us from standing here in front of you and having the honor of telling our story. And now, let's begin our story with the mechanical engineer, Mustafa.
From the moment the machines rose to the purpose, the mechanical team decided to design an ROV that features with manipulation, speed, and stability. And in order to do that, we studied the 2 things designed for motors adjustment that provide those features, which are the vector and the linear adjustment. Our old prototype ROV had the linear adjustment. It had four motors that is fixed horizontally to allow full thrust and forward motor, but unfortunately the vehicle could not rotate around its center. So we modified this in our Triton. We put 2 motors in the middle of the vehicle, horizontal to allow it with the full thrusting, and beneath it we put 2 motors opposite to each other. Triton is almost a dry hull vehicle, and along this journey we didn't observe any dry hull vehicle that is capable of moving lateral directions, and this is a feature we'll probably present to the customer in our Oceanus. As for stability, we used tether splitter. Why tether splitter? Because the air inside the splitter will make it float, and when we use the tether without the splitter, we noticed that the force was exerted on the ROV which caused it tilting, but with the splitter, it allowed it with stability. The 1,250 gallon per hour Olsen pump and the 5 cm propeller were neatly chosen after many experimentation, which the result we displayed before in the technical report. They are the most mechanically efficient and easily controlled. Now, my colleague Ahmed will return with you and talking about what. Thank you.
Hello, I am the mechanical engineer of this company, and today I'm discussing about first, tube dimension, second, the center body, so ballast system for the manipulators. First, the tube dimension. Sphere diameter 110 mm wide and 400 long, and with thickness of 10 mm. Such diameter is one challenge for the electrical team to make small electrical board, but it was useful in the financial state to reduce the cost. The bigger the diameter, the double of cost of this one. Second, center point. We want to have the center point at the same place in our center of gravity. So it will be more maneuverable, move easily, and the mission will be perfect. We test that by the simulation in SolidWorks. We serve ballast system. We insert our manipulator with ballast system, but we have a problem. Our Triton was positively balanced, and to adjust that, we will add 1 kilogram to Triton to be slightly positively balanced. Finally, we try to integrate 2 manipulators. Each manipulator with a caloric damper can hold any structure, any cylindrical structure, like the BIA, BIA handle, and the plug. And each manipulator is rated by perseline, cape, AC cape, and cape with O-ring routed ends. And now, research will be tell you how to construct our ROV.
After knowing missions supplied by MATE and dimensions required, we begin to construct our ROV regarding to Oceanus policy. First, we designed our ROV on SolidWorks. After that, we begin to choose our material. We choose our material. We have 2 choices. First choice was PVC, the material of our first prototype, or we search for a new one, and we choose acrylic. Acrylic, stronger, and minimize water leakage. Then we begin to simulate our ROV using fluid simulator ANSYS by using the most common equation, K-epsilon equation. And the result was acceptable as the dome decreases the pressure and the water distribution on our ROV, which make it move more smooth. After that, we begin to implementation of our ROV, but how we control it will be with my friend.
Since we started building a Triton, we decided that the electrical system must be full of features, and at the same time, it must not be complicated, so as to be easily troubleshooted. To begin with, I'm going to describe the electrical system inside the ROV. Inside the isolated electronic can, there are 5 different circuits. The first circuit, and the most powerful one, is the H-bridge circuit from Summer 2. It controls the speed of the forward, backward, upward, and downward thrusters. The second circuit is the relay circuit. It controls the manipulators and other stuff that doesn't need any speed control. The third circuit is the safety circuit. Actually, every motor in Triton has a 5 ampere fuse and a current sensor to detect any current consumption. The fourth circuit is the sensor circuit. It gathers all the data from the sensors and sends it to the driving stations through the tether. The fifth circuit, and the most important one, is the controlling circuit. It controls everything inside the ROV. It receives the data from the driving station and decide which motors should run and assign speed to the H-bridges. We use a panel tilt camera inside Triton to give the pilot everything that he needs to accomplish mastering piloting Triton. Also, another camera is fixed here on the arms so that the pilot will maneuver easily. Many problems face us, like having the ground common between the motors and the cameras. So when any motor started to thrust, the camera started to dim. So we used an LC filter to filter the ripples and the noise. And now I'm going to speak about the driving station. Oceanus Triton's Triton is driven using a joystick. The joystick sends the data to the laptop, and the laptop starts to unpack the data and send it through the USB to serial to the tether, and Triton starts running. Now, Maisara will speak more about the sensors.
In our company, we aim to provide a panel that is providing the easiest industrial ROV. Therefore, many sensors have been used, such as the pressure sensor, 3-axis compass, 3-axis accelerometer sensor, the temperature sensor, the water detector, and the current sensor. First, the pressure sensor by Honeywell, which is ADC control. Its function is to display depth in order to help the pilot navigate easier, and it sends analog readings. Also, as a future work, the ROV could maintain the required depth. Second, the 3-axis compass, 3-axis accelerometer sensor has a background coupling which communicates the ask-person protocol. Its function is to display Triton's head. Third, the temperature sensor LM35 is placed next to the H-bridges to sense any rise in the temperature of the circuit that might occur and send an alarm to the driving station. It sends the analog readings, which can be converted into Celsius degrees. After that, we move on to the water detector. It's used to monitor any leakage in the ROV underwater. It sends analog digital readings. Last but not least, the current sensor pilot current. It's used to calculate the current of the thruster and give the pilot an alarm in case of any high current consumptions. It sends the analog readings. And now, I'll leave you with Roman to continue with the safety.
When we first started the process of manufacturing Triton, our aim was in the perfection of our ROV, but also we cared for the safety of our team members as well as the safety of Triton. All the team members followed the common safety rules, as they wore safety goggles, hearing protection, and rubber gloves. And if we're working or repairing any electrical circuit, we make sure that the batteries are disconnected and use it to care about us. They never allow us to do things, to do sorry.
Like my mom
We
was
have,
like
yeah.
And this acrylic,
We just design it on the
by
SolidWorks and
Oh.
have the materials, the acrylic
Yeah.
sheet ready, and then the cutting of the laser starts.
Okay. Yeah. Could you describe who is your poolside team?
Yeah, our pilots, co-pilot, and featherman.
Okay. And do the other members of the team have supporting roles?
Yeah.
Those
Yeah,
from
of
outside,
course.
the main piloting,
Okay.
as it's eligible from our competition.
All of us think of the mission, of how we will do the mission and the strategy. All of us have been putting the strategy of the mission.
Okay.
And some of us are just the non-technical things, like the presentation, so we help them with this. And we're trying to help them as much as we can.
Here,
We're hoping that we can do something
There's a
similar.
C# language of Visual Studio 2012. That's the interface between the joystick and the art.
Here,
So you're using C#.
yeah.
Did you use an existing library?
Yeah, DirectX SDK.
Oh,
Actually, I got a lot of help from the internet forums.
And here you can see the video of manufacturing going on.
oh, look at that. Oh, so this is your laser cutting system.
We design it and we cut it in the machine.
All right.
That's how laser cutter.
And we got about 4 or 5 minutes here.
That's a really nice. It's a nice resource to have.
Yeah.
It's a very good tool.
The thick acrylic,
Yes.
requiring a good material not to be broken.
Yeah. I do appreciate in your presentation the PowerPoint and referring to it, and that is a very nice touch. That was
Actually, there's also the video that our CEO, for the media outreach, our CEO was interviewed in Rotana, Australia, and he talked about the MATE Center and the ROV.
After
And-
winning the original competition.
Yeah,
Yes.
on the
Okay.
regional. And in the regional, we won the first place, best design for our our Triton,
And best
and
point.
best pilot, we won the best pilot award, and best presentation as well. Hopefully, it's all happening.
Yeah. So let's see.
Yeah,
So how?
Has to be getting stuck.
The hyperthermal vent opening.
How much of the vehicle is all new from this team this year, or is some reused from previous teams?
And that's the first years for this team participating in the components for
And so everything is new, so nothing reused from previous years.
We had the first prototype vehicle by BBC as used to describe it and shape us the critical floating, and we changed the
When our Triton is
So yes, and to see the reading by ADC.
because we changed our ROV, our Triton, our original ROV.
This is just plugged into the computer.
Like a runner only for you get all the supports on
Oh yeah.
It would be like a board we design it, applicable on anything within the field.
yeah.
One thing I liked about your presentation was that you did some mathematical analysis. You told us a little bit of theory. You gave us some numbers. You clearly understand your buoyancy, and so you did some good engineering work.
What do you think, sir, of Triton?
I think it's great.
Yeah.
It's a good thing.
I'm excited to hear how you guys do in the pool.
Actually, the organizer of Oceaneering in the regional competition, it's for Triton, and said it's a masterpiece. And
Yeah, and with a presentation on it
And he
to
actually
explain to others.
explain to the rest of the ROV teams how
Actually, the explorers
yes,
team
how
also
the isolation and how this piece is just Triton.
Okay. Well, you have much to be proud of.
Yes.
And
Very proud.
and the way the team has come together to overcome the damage and the problems, that is priceless, and it really reflects the maturity of how you work together for what, a first-year team.
Yeah.
So absolutely well done. We look forward to seeing how you perform in the pool.
And your all smiles are a lot of fun. I like
Yeah.
Yeah, that was cool too yesterday. No risk, no fun. No risk, no fun. We risk. We had fun now.
Yeah, got it all. Excellent. Oh, well, thank you. Oh, my goodness. Wow, thank you very much. Oh, my goodness. Oh, these are beautiful.
Thank you.
No, is this
papers and
Yes.
there's papyrus on it.
actual papyrus? And oh, it's beautiful. Very cool.
Oh, that was the other thing.
Let's take a good photo.
That I thought was captivating. The way you weave the journey as a theme to unite your presentation. I thought that was that kept me and how you connected the pieces. So that was a good thing.
Please take a very photo with you.
Yeah.
Oh, absolutely. Thank you.
Okay. Make sure.
I am excited to see you guys come back. Yeah.
Oh, your robot.
Okay.
Get up front. You guys are up front. We're in the back.
Yeah.
You guys are more important than we are.
No way.
It's true.
I'm good.
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 All right, guys.
Thank you.
Well done.
Thank you very much. Thank you. All right. Enjoy. Thank you.
Thank you so much. It's great.
All right.
Thank you. Thank you.
Really well done. We really appreciate you being here. Thank you.
Don't miss me. Great. All right, what are you in the pool? 2.5.